Hey everyone, welcome back. Today I'm going to show you how to build the electronic Plinko game board completely from scratch. We have got a 3D printed triangular board, custom PCBs designed in EasyEDA and fabricated by JLCPCB, infrared sensors to automatically detect where the board lands, an LCD display and a speaker for sound effects. Let's get into it. So for those who don't know, Plinko is a classic game where you drop a ball at the top of the pig board and it randomly bounces its way down before landing in one of the scoring slots at the bottom. The ball path is completely random. It's basically a physical demonstration of binomial distribution. The twist in my version is that everything is automatic. When the ball lands in a slot, an infrared sensor detects it and the score is calculated and shown in the LCD, and the speaker plays a sound effect. No manual scoring needed. Let me walk through the circuit. Each scoring slot has a pair of infrared components, a transmitter LEDs and a phototransistor receiver. The transmitter constantly beams infrared light across the slot to the receiver. When there is no ball, the infrared beam reaches the receiver, which conducts and pulls the output high, about 3 volts. That's above the ESP32S3 logic high threshold of 2.475 volts, so the microcontroller reads it as high. When a ball drops and blocks the beams, the receiver stops conducting. The output drops low down to about 0.3 volts, well below the logic low threshold of 0.825 volts. The ESP32S3 detects the low signal and registers a score for the slot, so the system is active low. A ball triggers a low reading. All 3 boards were designed in EasyEDA and fabricated by JLCPCB as part of EasyEDA Spark 2026 completion. You can see them fresh out of packaging here, and they even come with the EasyEDA Spark branding on the tilt screen. There are 3 boards in total. The transmitter board holds all 13 infrared transmitter LEDs with current limiting resistor, one for each scoring slot. The receiver board holds all 13 phototransistors with pull-up resistors. The output connects to a GPIO pin on the ESP32S3. The main controller board holds the ESP32S3 WROM1, the ST7789 LCD, the start and stop buttons and the speaker. It also has a clearly labeled headers for all the GPIO connections. Here's the soldering process. The transmitter board was pretty straightforward, just SMD resistors and through-hole infrared LEDs. The receiver board was similar, but I also had to solder the phototransistors and the output header pins. And here's the main controller board after soldering. The ESP32S3 sits in the center with the LCD module and the buttons alongside it. I connected everything with the ribbon cables and 2-port connectors to keep the wiring manageable. The board itself is 3D printed in 2 parts. The first part is a triangular pig board. You can see all the metal pigs pressed into the holes in the print. The second part is the base piece, which houses the scoring slot at the bottom where the infrared sensor sits. I press the M2 screws through the top as the pigs. It gives a nice metallic look and the size is perfect for the ball to bounce off cleanly. Here's the fully assembled board. The receiver PCB sits at the base of the pig board, hidden inside the slots. The transmitter PCB sits directly opposite the other side of slots openings. The controller board with the LCD and buttons mounted at the bottom, facing outward so that you can see the display and reach the button easily. The firmware runs on the ESP32S3 using the Arduino framework. Here's how the scoring works. The slot points values are based on the actual binomial probabilities of where the ball is likely to land. The center slot has the highest probability, so the score is the lowest, just 3 points. The outer slots are the rarest to hit, so the score is the highest, 3,200 points each. This keeps the expected value roughly equal across all 3 slots. The LCD shows 4 things in real time: the last slot the ball landed in, the total number of balls dropped, the average points per ball, and the game status. The speaker plays a drop sound when the ball enters, a pitch skewed tone when it lands, and a full fanfare when it hits a high value slot. And that's the Plinko board game. This project was built for the EasyEDA Spark 2026 competition. All the PCB design files and the 3D print files are available on oshwlab. Links are in the description below. If you enjoyed this video, please give it a like and subscribe for more makers projects. Let me know in the comments if you would like to build one of these yourself. I love to see your version. See you in the next one.
$85,000 cash prize pool. The EasyEDA Spark program is now open worldwide. Material costs largely reimbursed. Earn a $100 coupon per finished project. No limits. Top creators invited to 2027 conference and free factory tour. From idea to reality, design it, build it, share it. No limits, infinite rewards. Submit your project now.